Welcome to the BIH-CUBI HPC Course Number 1041 with the topic Conda Basics. You're watching version 0.1 and I am Manuel Holtgreve. The agenda of this course is as follows. We will start by explaining some fundamental information on our courses in general and this course in particular. We will then give a short executive summary style synopsis. We will then introduce the Conda package manager, followed by describing the Bioconda channel and package repository. Finally, we will point you at resources where you can get help with Conda and Bioconda. Please note that most of this documentation is based on the Bioconda tutorial by the Bioconda team. You can see the web address of the tutorials on the lower right of this slide. As with all courses, we start with a short overview of our courses in general. The BIH-CUBI HPC courses are numbered roughly following the Anglo-American college course system. For example, course number 1001 would be a level 1, meaning introductory course on topic 00, which is a general introduction course number 1. We use an extended version that has 2 digits for the topic, and 1001 would be the equivalent to the well-known 101. Each course corresponds to one slide deck and is available as a pre-recorded video online. When doing live courses, we mix and match slides from different courses. This particular course introduces Conda and Bioconda. If you are a principal investigator or group leader on the HPC, then you will learn what Conda and Bioconda are and how it can make your work more efficient by helping you with software installation. If you are a user of the HPC system, you will learn the basics of installing Conda with Bioconda and installing bioinformatics software packages using Conda and Bioconda. Let us start with a one-slide executive summary. As we will see later, Conda is an open-source user space package manager. This means that no administrator privileges are necessary for using it. It is written in the Python programming language, but there is also a faster C++ front-end called Mamba. Conda provides the possibility to install binary packages such as BWA, but also Python, R, and Perl packages. Bioconda is a package repository called channel in Conda terminology with bioinformatics related packages. You will find almost every relevant bioinformatics software there with 7,000 plus packages. Anyone can contribute, and Bioconda has a vibrant community of more than 850 contributors. Bioconda is an open source software, and you can find the documentation, source code, a ticket tracker at GitHub. Linux has first-class support and Mac has second-class support in Bioconda. This aligns more or less with that most heavy lifting in bioinformatics is done on Linux anyway. We suggest that you start using Conda and Bioconda for all of your software installation needs. We at BIH-CUBI HPC Administration will only provide system-level software to our users and suggest that users use Conda for installing their software. We now come to the main section of this course with the topic of Conda. Conda is a package and environment manager. In this respect, it is similar to the Linux package manager apt and yum, but it is more flexible and not bound to a certain Linux distribution. On the right-hand side, you can see the different flavors of Conda. Conda itself is only the package manager. To run it, you will need Python and some base packages, which are bundled together in the Miniconda distribution. We generally recommend installing Miniconda. Optionally, you could also install Anaconda, which consists of Miniconda plus about 150 high-quality Python packages. Conda allows you to set up so-called environments with software packages. The main advantage is that the environments are isolated from each other, and you can install one version of a package in environment A, and in a second environment B, you install another version of the same package. One major feature is that users can easily create their own packages and provide so-called channels, which are package repositories. Popular channels such as Bioconda are constantly updated, and you can easily install updated packages from these channels. Conda allows you to install pre-built binaries such as bioinformatics software PWA, but also for binary Python libraries such as SciPy or NumPy. Such binary packages are linked to libraries in the same environment. Conda packages have a specific version or channel. You can only have one version from one channel installed at the same time. Packages define their own requirements, which are usually from the same channel, but might also be from some predefined other channel. As explained earlier, packages are organized in channels. Different channels might contain packages of the same name with different or same versions. The most important channels are Conda Forge, Bioconda, and defaults. Conda Forge contains most dependencies such as NumPy, SciPy, or R-CRAN packages. Bioconda contains most bioinformatics packages, including software such as Salmon, Star, SamTools, etc. The defaults channel contains packages built by the company that originally built Conda. You can find packages by various means. For example, you can search the Anaconda website or the Bioconda package index website. You can also use the built-in Conda search command, as you can see on the top right. Packages have versions, build numbers, and build hashes. In most cases, installing packages will just work, and you can focus on selecting the correct versions. The build hashes also contain dependency information, which is important for selecting consistent NumPy versions, for example. Let us now do some practical exercise. You can follow along on your own. First, we download the mini Conda package from the Conda website. Here we show how to install it on Linux. The downloaded packages is a self-installing package, sometimes called sharbal. We call the installer shell script with the parameters -s, -b, and -p. We select the installer prefix with -p and install it into the folder miniconda 3 inside of our home directory. The parameter -b makes the installer run in batch mode and suppress interactive questions. The argument -s makes the installer leave our .bashrc file alone, which is recommended as this often causes trouble in HPC environments. Next, we activate the Conda installation by sourcing the activate script. This will activate the base environment, which will be indicated by extending your shell prompt by base in parentheses. We try out our shiny new environment by installing the Mamba package. This is a faster replacement for the Conda package manager. It does not implement all commands of Conda, but we recommend it for using whenever possible because it's so much faster. Let us now look at the list of common commands. You can list all available environments with mamba info-envs or member env list. New environments can be created with mamba create, and you can remove them again with mamba env remove. For activating an environment, use conda activate and conda deactivate to deactivate it again. By default, mamba will not provide this functionality, and you can just fall back to conda here. For installing a package inside the current environment, use mamba install. Finally, you can list all installed packages in the current environment with mamba list. Let us close this section with two hints. First of all, the real pro tip, keep your base environment clean. You should probably only install mamba as an additional package. Second, don't be shy to create environments. For example, create one environment per workflow or project. In the next section, we will shortly focus on Bioconda. In our second practical exercise, we activate the Bioconda channel. After having installed Conda, you will only have the defaults channel configured. You can use the commands on the right to activate the Bioconda and the Conda Forge channels. Please note that the order matters here. Channels are added first, will have a lower priority. You can bump the priority of a channel by prepending it again. You can verify the results by looking at the .conda.rc file or calling Conda config show channels. In the next practical session, we will set up a small environment with bioinformatics tools. We will call the environment utils. We start by activating our mini Conda installation. We then create the environment with mamba create-y-n utils bwa semtools bcf tools. Mamba create creates a new environment. -y will confirm all questions that would otherwise be asked interactively and just answer them with yes. -n utils creates the environment with the name utils. The remainder, bwa, semtools, bcf tools, are the names of the packages to install. After activating the environment with conda activate utils, we will have access to the bwa command. We can now install additional software with mamba install. Note that it is generally faster to specify the packages when creating the environment. We can list all packages in the current environment with mamba list. All existing environments can be listed with mamba env list. We end this section by pointing you at the Bioconda website. There you can find more documentation, help, and also a useful package index. The package index contains additional information such as packet forward and reverse dependencies, as shown here in the screenshot, for example. This is also useful for discovering new software. The last section consists only of one slide and lists some public help resources. First of all, consult the Bioconda documentation at bioconda.github.io. You can also ask questions on Stack Overflow using the Conda tag. The Bioconda community has an active chat channel on Jitter, and you can also ask questions in their issue tracker. Please be aware that we as BIH-CUBI HPC administration cannot offer support for Conda. Please feel free to ask on the HPC Talk website though. This is the end of this course. Thank you for watching it. You can find more information on our website and the BIH-CUBI HPC documentation website.